This video is about equilibrium. So the key in the question is the Gibbs free energy of the reaction has a negative value. The concept of this question is Gibbs free energy versus Kc. So the relationship between Gibbs free energy and Kc can be seen in this equation right here. And so to see how the two variable correlates, we're going to set temperature as a constant. And temperature will be set as 298 Kelvin, which is just standard room temperature. And we're going to change our Gibbs free energy at different values to see how that affects our K value, our equilibrium constant, using this equation right here. And all our Gibbs free energy is in the units of joules per mole. So at Gibbs free energy, when it's at 1000 joules, the equilibrium constant is 0.668. And this is rounded up to 3 significant figures. And when Gibbs free energy is at 500, our K value is 0.817. And when Gibbs free is at 0, equilibrium constant is at 1. And when Gibbs free energy is at negative 500, we get equilibrium constant of 1.22. And when Gibbs free energy is at negative 1000, we get equilibrium constant at 1.50. So we can see a clear correlation that when we decreases Gibbs free energy, our equilibrium constant will increase. And you can see at the point that it changes at Gibbs free energy of 0. So if it's above 0 when it is positive, our equilibrium constant is less than 1, which means there are more reactants than there are products. And that means at that point, the reaction favors the reverse reaction. But when Gibbs free is a negative value, the equilibrium constant is greater than 1. So there's more products than reactants. So the equilibrium point shifts toward the right. So it's favoring the forward reaction. And this makes sense because Gibbs free energy indicates the degree of spontaneity of the reaction and how much it favors the forward reaction. So when Gibbs free is negative, there's more forward reaction, and so there's more products than reactants, and vice versa. So if we were to go back to our question A, answer A, so it says at equilibrium there are more products than reactants, so that is true. But we should also look at other options. So it says at equilibrium constant has a negative value, so equilibrium constant cannot have a negative value. It only changes between being smaller than 1 or greater than 1. So B is wrong. And then C, equilibrium shifts to the left. This is the opposite. It actually shifts to the right because when Gibbs free negative, it favors the forward reaction. So C is wrong. And D, the reaction has reached completion. So we know that it's a reversible reaction and there's no completion. It only reached equilibrium. So D is also wrong. And so our final answer is A.